Welcome to the latest development update for the upcoming Acuity fully decentralized atomic swap exchange. The main purpose of this exchange is to facilitate fully permissionless trading between currencies in the Acuity ecosystem, such as ACU, and currencies on other blockchains, such as Ethereum. Later, it will be possible to trade many other pairs, even outside the Acuity ecosystem. And what I'm going to show you today is a little deep dive into the source code of how the exchange works. So if you've seen the previous video, you will know how some of the user interface is operating. And I'm just going to give you a little deep dive into how that actually works. Okay, so the OffChain Worker is a Rust application. And the purpose of this application is that it listens to the Acuity and Ethereum blockchains and indexes information that is important for the exchange. So especially on Ethereum, it's very expensive to store information, to index information on chain. And so having an off-chain worker, just listening to the blockchains and indexing relevant information in the blockchain means that the front-end application can be very fast. So it's a Rust application, and this is the entry point for the program. The first thing it does is set up the database. So we're using the RocksDB database, which is a key value store, and the column family concept. So that's sort of analogous to a table. So we set up these column families. And then we set up three different tasks. So we have the WebSockets task. So the purpose of this is that the front end can connect. So the exchange running in the web browser, it can connect via WebSockets to the off-chain worker and retrieve the indexed information. We also have a task that connects to Acuity, listens for events, writes them to the database, and then the same for Ethereum. But today I'm going to concentrate on the WebSockets task. So if we scroll to the bottom, we will see this is the function for the WebSockets task. So we just listen to the network and we wait for a connection to come in, and then we spawn a new task specifically to handle that connection. And that task is this function here. And we simply listen in a loop for messages coming in on that connection from an instance of the front end, and then we reply. So we wait for request messages, and then we reply with response messages. Okay, so of course, because we're using Rust, everything has to be correctly defined in the type system. So here we have a type for the request message. So this is an enum, an enumeration, and we just have two different types of message. So we have get order book and get order. And we're using the SERD system. So this is Rust's serialization and deserialization technology. And we use this to serialize and deserialize from Rust data types into JSON, which is used for communicating across the web. And here we've just set the tag to type. So what this means is in the JSON representation, the type is either get order book or get order. And then of course we can see for get order there is an additional parameter, which is the order ID of the order that is being requested. So in our loop that is listening for messages from the front end, so we have a match statement, and so we're either looking for get order book or get order. And in the case for get order book, we query the database. So the database has a list of all the orders, of sell orders of Acuity. And these are actually, these are listed in order of the size of the order. So the amount of ACU that is in the sell order, that's how it's sorted. So this is mainly as an anti-spam system. So if someone makes a lot of very small orders, they will be at the bottom of the list, and then the big orders will be at the top. And then, of course, on the front end, you can sort the orders whatever way you want. So we query the database. We do a little bit of processing just to extract the correct information from the database, and then we create the order book. So the order book is it's just a vector of orders. So a vector it's kind of like an array. So we have the order struct here. So we just have the order ID. So that's the order ID is kind of like the identifier for the order. And the order ID is automatically generated from the static information that does not change in the order. So for example, the sell price and that sort of thing. And then we also have the current value of the order, because that can increase and decrease. So we create this vector of orders, and then we need to wrap this in a response message, like so. So we can see for response message, we have two types of response. We have the order book and an order by itself. So the order book is a vector of orders. The order is currently just an order. And then we serialize the response to JSON, and then we send it out back to the front end. And then for get order, so it's a fairly similar process, but we're just getting a single order. Later on, this request will also return all of the buy locks that are associated with this order, but that has not been implemented yet. So that's what I wanted to show you on the OffChain Worker. And we can now take a little look at the front end. So the front end is written in TypeScript, and it is using the Vue framework. So this little class, this just initializes the connection to the OffChain Worker, and it waits for messages. And then there's a couple of other methods. So if any other part of the front-end application wants to make a request, so they can call one of these methods. So for example, get order book. So we set the type to get order book, and this is, of course, the type is get order book, like that. Or we can call get order with the order ID. And so we converted from the TypeScript object into JSON, and then send it out over WebSockets to the OffChain Worker. And then the OffChain Worker will respond with a message, so either order book or order. And this little loop is actually just listening for all of the messages from the OffChain Worker. It's all being processed in a single place. And the idea is that any message it receives, it will put it into the Vuex state machine. So this is a system in Vue where all of the information that you may want to display anywhere in the app can be stored in one place. And then any part of the app that is displaying that information, it will just automatically be updated. So this is a great way whenever new information is coming from the OffChain Worker. If that's being displayed on the screen, then it will just automatically be updated immediately. So if we get a new order book, we call order book ACU set. If we get a new order, we call order ACU set. And then this is just the configuration for Vuex. So we can see we've got two different types of states. So we have the order book, and we have individual orders, and then we have the mutations. So order book ACU set and order ACU set. So this is what's being called whenever we get a message from the OffChain Worker. Okay, so I will show you how that works on the front end. So this is the front end application for the exchange, and then we have the Vue browser extension on the left. And so we're actually able to look into the Vuex state machine and see how things get updated. So if I click on Acuity sell orders, so it immediately makes a request to the OffChain worker to get the order book. We get a message back, and then we execute this this mutation in the Vuex state. So it's just updating the order book, and then of course that's just updated on the screen. So we can see that after that first mutation, we have an order book here, and we have the 2 entries. And if I just want to so let's say I want to go into one of these orders. So I would want to see the existing buy locks, or maybe add a buy lock of my own. So I might click here, and so then the web app makes the request to the backend. I want to see this order, and so we get a new mutation to the state. So order ACU state. And we can now see in the state we have keyed by the order ID. We can pull out the specific order information, and then that gets put onto the page. So the next step would simply be that because we're already indexing in the database all of the buy locks for each order. So the next step is to actually, when we make this request for retrieving the information for an individual order, then it should also return all of the buy locks. So that would then be included in the Vuex state machine, and then it would appear on this screen. So I hope that gives you a good idea of how the whole system is coming together, and I hope to talk to you again soon. Thanks very much.